Okay, hi guys. This will be a quick video. I'm hoping less than 5 minutes. Several of you have emailed me regarding questions 22, 23, 24, or whatever on the chapter 10.5 homework. Um, and I will admit up front that it's not quite like anything we did last week. We actually did one problem, but one isn't enough. So I want to walk through this. So I'll read it. You guys can pause the video and catch up at any time you want, but I'm going to go through this. A certain strain of bacteria, spelled wrong, grows continuously. If a colony of bacteria starts with 370 bacteria, has 2,960 bacteria after 80 minutes. All right, stop right there. First off, the grows continuously is our clue that we're going to use this formula for continuous growth. A of t equals A naught or A sub 0 times e to the RT. That's our clue. The continuous growth says use that formula with the E in it. Okay. Now, first sentence says the colony of bacteria starts with 370 and has 2,960 after 80 minutes. So let's plug in and see what that says. We have 2,960, okay, equals 370, okay, e to the r times 80. By plugging in all of that information into that formula, you can see that we're missing the r value. Okay, again, let's go back through this. A of t is the amount after some time. We have 2,960. A sub 0 or A naught is the initial amount. So this said starts with 370. That's the beginning amount. Okay. And after 80 minutes, if the time was 80, it grew to this. All right, real quick solve. Take my calculator. I'm going to divide both sides by 370. So I have 2,960 divided by, oops, got to turn it on. Oops, got to get a calculator that works in the dark, not solar. Turn it on, clear, click. So 2,960 divided by 370, enter, I get 8, okay? So this is 8 equals e to the 80r, okay? ln both sides, ln of 8 equals ln of e to the 80r. The beauty of the right side is you can bring the power down, 80r times the ln of e, but the ln of e is really cool because it just is worth 1 and it drops out of the problem. So if we divide both sides by 80, okay, so let's do that. I have the ln of 8 divided by 80. I get, I'll come up here. I get 0.025993, whatever. That equals R. That equals the R value. Now, we talked about this last week. That's the rate. If it said, okay, that's the rate as a decimal. If the problem had said, what's the rate? You would say it's 2.599% is the rate. So in math, we make a distinction between what do you answer. The answer is 2.599, or whatever it said to round to. Don't worry about it, okay? But we actually use the decimal. Now, this particular problem didn't ask you to find the rate. You just had to do the rest of the problem. All right, so speaking of the rest of the problem now, okay, find the rate of growth. Well, this one did. I'm sorry, the ones in mom don't. How many bacteria will there be after 1 hour? So now we can go back and our formula now is rewritten to A of t equals 370 e to the all of that, 0.025993 times 1 hour, okay? Now, here's the trick. Well, actually, let's write this as the formula, because that's our new formula now that we found the rate, okay? But it said how much after 1 hour. The problem is the original information was given to us as minutes. So that's the unit we have to use for time. So even though the problem said 1 hour, we have to use 60 minutes for time. Okay, now this problem is just simply arithmetic. That's all there is to this problem. Okay, so going to go e raised to that power, whatever that is, times 370. Let's see if I can do it. E raised to the, let's see, 0.025993 times 60, close parentheses, boom. Nope, syntax error. Doesn't like it. Oh, I know why. Delete. I put an extra parenthesis in. So this quantity on my calculator shows a 4.7568, whatever, times 370. So after 1 hour, we have 1760.0244, whatever. But all of the homework on mom says round to the nearest whole unit. Why? Because you can't have a fractional part of a bacteria. That's what you're measuring for. How many bacteria will there be after 1 hour? So you would answer 1760 bacteria after 1 hour. Okay. All right. The last one, some of the questions on mom, I set up 5 questions for chapter 23 or problem number 23, but I only told mom to pick 3 of them. So it's totally possible that everybody could get a different problem. Okay, so I want to do this extra one here. It might show up on another problem, it might not. I need to erase some work. Like I'll erase this problem right here. Okay, how long before the population triples? Okay, so here we go. We have this formula, A of t equals, we now know that A naught or A sub 0 is 370, e to the 0.25993 t. That's our formula now. Okay, how long before it triples? Well, triple means when does the initial number of bacteria become triple? So we write 3 times 370 equals 370 e to the 0.25993 t. Okay, we want to divide both sides by 370 and look at that, they all cancel out. So we end up with 3 equals e to the 0.025993 t. Okay, it becomes the same kind of problem as this. We're going to take the ln of both sides. So the ln of 3 equals the ln of e to this junk. I don't want to write it. I'm just going to say junk. Okay, but we bring the junk down because it's a power. So we have the ln of 3 equals 0.025993 t times the ln of e, but just like before, the ln of e is worth 1. So we're going to take the ln of 3 divided by that mess. Let me see if I can do it. ln of 3, and then to divide both sides to get t alone, we're going to divide by 0.025993. Okay, and we end up getting 42.26569 equals t. Now this time, this is time in minutes, okay? But you can have decimal fractions of minutes. So read whatever the problem says in MOM. If it asks this, it's okay to have fractions or decimals of a minute or a second, but it's not okay to have pieces of a bacteria, decimals or fractions of a bacteria. So whatever this rounds to, it rounds to. I don't know. All right, I hope that helps you. Okay, good luck.